Hello, welcome back for another video for chapter 6.4. It's over adding and subtracting radical expressions. So it's going to be going back to some of what we learned with adding like terms. When we add two groups of monkeys together, we have all monkeys. When we add two groups of X's together, we have all X's. And so now when we combine radicals, as long as they're the same radical, we can combine their coefficients. I'll show you how that works. So we're using these two radicals, or this definition here in this rule. So the definition says two radicals are said to be similar radicals if they have same index and same radicand. So cubed root of X and cubed root of X, right? Or square root of xy and square root of xy. They have the same index and the same radicand. Okay, and the rule says to add or subtract radical expressions, put each simplified form in its simplified form and apply the distributive property if possible. We can add only similar radicals. We must write each expression in simplified form for radicals before we can tell if the radicals are similar. So let's do some basic ones. We have 6 of these square roots of 3, subtracting 5 square roots of 3. So we have 6 minus 5 of these things. So we can really write this as 6 minus 5 of these square roots of 3. So we really just have one of them. Okay. Now we're looking at only the variable pieces. Okay. So we have y times the square root of a and y times the square root of a. We have 6 plus 7 of those. So we really have 13 of those y times the square root of a. That's what makes them like terms. Letter C. We have 4th root of 2, 4th root of 2. So we can add the 6 plus 9 and get 15 4th root of 2. Now we can extend this to some bigger things. And now letter D, we have x times the square root of 6 in each of these, so we can combine 5 minus 3 minus 2 of these x square roots of 6. And that means we have 0 of them, so we just have 0. Okay, now E, we don't have like radicals, so we have to simplify them, so we do. So I'm going to go a little bit quicker on these because we should have gotten practice on the prior homework simplifying these radicals. So square root of 8 is really 2 times the square root of 2. And 32 is going to be, that's minus 4 times the square root of 2. And 18 is minus 3 times the square root of 2. Because I could split these into, this is going to be the time I do that. So this is what you're doing in your minds. You're figuring out if there's a factor that's a perfect square root inside of each of these. And there was a square root of 4, square root of 16, square root of 9. So now they all have a square root of 2. So I can say 2 minus 4 minus 3 times the square root of 2 is 2 minus 7, or a negative 5 times the square root of 2. Likewise, I'm doing the same thing here. So 16 times 3 in here, so that's going to be 4 times the square root of 3 minus 3, and then 9 times 3 is in the square root, so there's going to be another 3 times the square root of 3 plus 2, and then the square root of 75 is really the square root of 25 times 3, so that the square root of 25 is 5, so 5 comes out in square root of 3. Okay, so they all have a square root of 3. So I've got 4 minus 9 plus 10 times the square root of 3. So I have a 4 minus 9 is a -5, plus 10 is a +5, times the square root of 3. And then D, they don't look to be the same radicals, but we're going to simplify them. So the square root of 20 can be, this is 9a square root of 4 times 5. And then that's B plus 7b, the square root of 9 times 5, and then we've got A, B. So that comes out, and then I've got 1, 1, this comes out, and then we've got 1, 2 there, 1, 2 there. Okay. So 9 times 2 is 18. I had an A out front and an A came out, so I have A squared and a B came out. And then I'm left with 5A. Then I have plus, over here, a 3 came out, so 7 times 3 is 21. And then A times A squared came out. B times B, B times B came out. So I have B cubed times the square root of a 5A and a B left over. And I can't combine these because they're not identical. So all of this would have to match all of this, and it doesn't. So sometimes they can't be combined. Okay, let's look on the back side. So letter H. So this is the fourth root. So there's no fourth root of 5 or x, but that's y to the 8 over 2, so that's y squared. So y squared comes out, and then we have the fourth root of 5x plus, and the fourth root of 405 I'm looking for something that has a power of 4 that's a factor of 405. So I'm going to take 405 and divide it by 5 and see what it comes up with. 81. And I know 81 to the 1/4, or the fourth root, is, oops, no. Okay, is 3. Okay, so 81 times 5 makes 405. So this is 405. The fourth root is the same as 81. So 4 times the fourth root of 5. So a 4, we've started with a y, and then x to the 5th, there's 1x comes out, and 1 stays under, and then y to the 4 divided by 4 is just a y. So another y comes out. Okay, we'll combine everything here in a minute. Plus, then over here, 80 could be 16 times 5. And the fourth root of 16 is 2. So we have a 2 and then the y squared original, and then x to the 5 divided by 4 is an x comes out, and then we have a 5x left. And notice that we have y squared 4/3 of 5x. This is a y squared, y squared 4/3 of 5x, x. Yeah, this is a 4th root. So y squared 4/3 of 5x. So I've got one of them, 4 of them, 2 of them. So we really have 7 y squared 4th root of 5x. It's a lot. Okay. Now, I, J, and K, we've got some fractions here. We're trying to add, so to get a common denominator, I first have to get this rationalized by multiplying by the square root of 3. So I have the square root of 3 over 3 plus the square root of 3 over 3. So I really have 2 square roots of 3 over 3. I have 2 of them. Remember, when you add fractions, your denominator stays the same. Okay, J. I want to add this fraction, and then I have to rationalize this fraction. So that becomes the square root of 6 over 6. But we don't have common denominators, so I have to multiply this fraction times a 3 over 3. So I have 3 times the square root of 6 over 6 plus the square root of 6 over 6. Now I can add the numerator. So I have 4 times the square root of 6 over 6. And the 4 over 6 can be reduced. So I have 2 times the square root of 6 over 3. And then I want to add these 3 numbers. So I have to rationalize these denominators. So this one's going to be the square root of 5 over the square root of 5. This will be the square root of 3 over the square root of 3. So I have the square root of 15, subtracting the square root of 15 over 5, plus the square root of 15 over 3. And this first one's really over 1. So we have to get a common denominator of 15. So the first one, I have to multiply by 15 over 15. So that's 15 times the square root of 15. Minus that fraction needs to be multiplied by 3 over 3. So it's 3 times the square root of 15 over 15. Plus the third fraction needs to be multiplied by a 5. So that's 5 times the square root of 15 over 15. So I have 15 minus 3 plus 5. So that's 17 square root of 15 over 15. So I gave you some basic ones and I gave you some trickier ones. Please reach out if there's any that you are still struggling with. Catch me back for the next lesson.